We got a JL audio on the bench, and this time it's a 4-channel. The customer states 1 channel is down on this. However, I know that there's no dead output transistors by the fact that this amp comes on just fine with no protection mode, and we don't get any DC offset on any of the speaker terminals here. It's all just 0 volts, which is what it should be. So the missing channel on this amp is gonna be either something preamplifier related, and one of the really common things on these is these switches in the preamp section get corroded or dirty inside on the contacts, and they just need cleaning. Very, very common. But I noticed when doing an inspection that out of the driver boards for each channel, one of them was not lit up over here. So we know that this is going to be a drive circuit fault on this channel. A pretty common issue on these amps is the solder joints on the surface mount resistors, especially these larger ones, crack and therefore don't make a connection on one of the sides. So the first thing I did was just go over some of the more accessible resistors here with my iron and a bit of flux just to refresh the solder connections on the ones I could easily get to. Didn't make a difference. So you can see we're missing the LEDs here. Let's see what voltage we've got on the LEDs from a good driver card. We've got 43 volts on one side and 41 volts on the other side, so about 1.5 volts, 2 volts over the LED, and that's referenced to positive rail. So we should have high voltage positive rail on this, which we don't. We actually have negative 10 volts. Using one of the good cards, we can see where the positive and negative rail voltage comes into the driver card. You've got positive rail coming in here on this pin and negative rail coming in here on this pin. So with our bad card then, we do in fact have positive and negative rail coming into the driver card. And the first thing those rails are going to see when they come onto the driver card are these 10 ohm resistors. These will probably work like current limiting resistors, and they'll blow first if something shorts rail to ground on the card. And if I check after the 10 ohm resistor for the positive rail on this bad card, it starts off reading positive rail, but then it sinks down to about minus 10 volts when the card starts to activate. So that tells me the resistors probably failed to a high resistance. When the card tries to draw current through it, the voltage drops considerably. And yeah, if I measure at points across it, we have a kilo ohm. Let's get these caps out of here, which will give me better access to the resistor. Out you come. Now's a good opportunity to check whether there is a short to ground or short to the other rail on the other side of the resistor, which would have caused it to fail. The resistor doesn't look visibly burned, which I'd expect if there was a dead short to ground or the other rail. But yeah, no shorts or anything here that I can see. Okay, let's give it a quick power up with the new resistor fitted and see if that sorted it. Not quite. So it seems that while soldering the positive rail resistor in, the negative rail resistor has also gone bad, or was bad anyway, because now on the other side of the negative rail one, we're reading positive 10 volts. So that tells me that that resistor is now out of tolerance. So these capacitors that we've removed are just smoothing ones. They just connect each rail to ground, so they're not necessary for a quick power up and test. So with both of those resistors now replaced, let's see what it's doing. Nope. Still not good, although this LED is now brighter. So I'm having a poke around on here. This is one of the good boards. As you can see, the LEDs are lighting up with the multimeter, checking on diode mode. This one here, though, is reading a short at 4 ohms. This one over here doesn't read a short, but it also doesn't light up. Wow, have the LEDs died? That's pretty rare. Yeah, man, both these are toast. One is a dead short, and the other one reads basically completely open. So I've got to find some replacements for these. Now, we know they have 2 volts across them. I measured that exactly on the multimeter. It's 2 volts. So what we've got to do is go to LEDs on RS components and filter by green, surface mount, 1 LED, forward voltage 1.95 to 2 volts, and the package type is 3216. Apply filters, and there's quite a few to choose from. I put the caps back in because I'm fairly confident. Let's power it up and see if we get those tasty LEDs. Oh yeah, these are quite bright. I measured the voltage across these versus the old ones and it's the same. So these are obviously just brighter LEDs than original. But the question is, do we have a clean sine wave? Booyah!